All right, let's go over chapter 2 for a little bit, just kind of a summary of what's going on in this chapter. Chapter 2 covers a lot of your basics as far as beginning constructions in programming, namely these three structures: sequences, selections, and loops. All right. There's a couple other issues that I want to get to at the end as well, but these are the big three. Whenever you're doing any kind of programming solution to a problem, every program is built on these three structures. And as we're just introducing these, keep in mind that selections and loops come up in chapter 3 and 4, I believe. So don't get too worried about them right now. Out of the way. All right. So the first one, sequences. Okay, this one's pretty straightforward. You have a series of statements, right? You do the first one, you do the next one, you do the next one, you do the next one, all the way down. So my example, making a peanut butter and jelly sandwich, you get the bread. Then you get the peanut butter, then you get the jelly, you apply the peanut butter, you apply the jelly, you put the bread slices together, and you eat it, right? You do them starting with the first one, until you get to the last one. That is a sequence. All right. The next structure, a selection, is a little bit more complicated because what you're doing here is you're making a choice. Right? You've got a question, and based on the answer, you do one thing or another. My example, getting up in the morning. Right. First thing you're going to do is wake up. Then you're going to ask the question, is today equal Saturday? All right. Now, in that if statement, you've got a condition. The condition is today equal Saturday. And what that is a question. Now, also in this chapter, you're going to see assignment statements, which look very similar because they use the equal sign also. So what you've got to do is you've got to look at the context of this statement. If it's an if statement, the equal sign is asking the question, are these two things equal? Right? And an assignment, which would not have an if, then you're actually assigning one value to another. Okay, but here it's a question. So what you're asking is today equals Saturday. And if that is true, then you do the action that immediately follows that, which is go back to sleep. Right? Now, in this one, I've put it together in an if-else statement. And basically the way that works is you do what's after the else if the condition is false. So if today equals Saturday is not true, then you go to the else and you do the action that's after the else. In this case, the action is another if statement where you check to see if today is Sunday. And if that's true, you go back to sleep, right? If that is also false, then you go to what's after the next else and you get up. So basically this construction says if it's Saturday, go back to sleep. If it's not Saturday, but it is Sunday, go back to sleep. If it's not Saturday and it's not Sunday, then you get up. All right. This was a little bit more complicated if than what we're going to start out with. And again, this comes up in chapter 3, so don't worry about it too much yet. But the whole idea of selection is you get to a point, you ask a question, and you do one thing or you do something else. Okay. The next one, repetition or looping, right? This is where you take a statement or a group of statements and you repeat them over and over and over. In my example, I wake up and I check to see if the time is less than 7:30 a.m. Again, a condition, and if that condition is true, I do what's in the body of that while loop, which is sleep 5 more minutes. Right? After I've slept 5 more minutes, I go back to the while statement and check the condition. If time is still less than 7:30 a.m., I go back in and I do the body of the loop. I sleep 5 more minutes. When I'm done with that, back up to the while statement, check the condition, time less than 7:30 a.m. Now, if at some point time is no longer 7:30 a.m., which could mean that the time is greater than 7:30 a.m., or it could mean that the time is actually equal to 7:30 a.m., right? As long as it's not less than 7:30 a.m., then I'm going to sleep 5 more minutes. Then I'm going to exit from the loop. So if the condition turns up false, I exit from the loop and I do that last statement where I get up. Okay. Like I say, while is a fairly common statement for looping and repetition. You might also have do untils and fors, which I know we talk about fors a little bit later. But for now, and for starting off, we'll deal with whiles. And again, whiles loops come up in chapter 4, I think. So that's actually a couple more weeks away. All right, the other big issue from chapter 2, variables. All right. Essentially, a variable is a location in memory where you can store a value, right? In 120, in the textbook we're using, we've got two types, numeric and string. So essentially what I'm saying is you got a location in memory. I could put a number in there, right? Or I could put a group of characters, which is a string, in there. A variable has a name, and this slide here really is talking about variable names more than anything else. But every variable is going to have a name, and you put something into that variable by referring to its name, which actually comes up on the next slide. But let's start with what's legal. Okay, so generally the rules of a variable name or any identifier is that it has to start with a letter of the alphabet, and then can be any combinations of letters and digits, and usually the underscore is okay, and that's usually about it. Different languages vary. Some languages are going to allow you to have other special symbols, some not, but for the most part, these are legal, right? Taxes, month, my name, right? My underscore name, payroll 2014, all these are okay. Notice on the my names, I did these two different ways. My habit has always been to do the first one, which is something known as camel casing. Camel, like the animal, camel casing, where you start off with lowercase, but note, I guess, let me back up. Notice what I'm doing. I'm putting two words together. All right. Now, first of all, I can't have my space name, and there's an illegal example of that coming up, right? I have to put them together. I can't have a space. So the problem is, how do you read it? How do you make it readable to someone else so they'll know that, like, the N in name is the beginning of another word, right? And there's two ways of doing that. You can do camel casing, like I was saying, where you put the first letter of the next word in uppercase, right? So my is all lowercase, and then the letter N in name is uppercase. And then when I'm reading it, I know, oh, it's my name, not Minami or something like that, whatever you would be if you put the whole thing together, right? Same thing with the next example. The underscore also is used sometimes to mark, again, the between words, so that I can read that and I know it's my name. When I started programming, I got in the habit of camel casing, right? If you want to do it with underscores between words, that's okay. But do something, because, again, it is M-Y-N-A-M-E, all lowercase, is hard to read. Maybe that one's not so hard to read, but I've seen them where they're really, really hard to tell that these are a group of separate words. Okay, take a look at the illegal ones. Starting anything with digits, that's illegal, right? Hit points with a space in the middle, that's illegal. Put them together, and then again, camel case or use underscore. Hashtag stuff, that's... For now, for this class, it's illegal, but you might get into a programming language where certain special symbols are actually allowed. Okay, let's say, again, for here, the only thing that's allowed is the underscore. All right, so for here, hashtag stuff is not going to work as a variable name. Things to avoid. Putting an uppercase as the first letter usually indicates that that is a class. I think this is on the homework, right? That's a class. So variables, and when I say avoid, what I'm getting at is there's certain conventions in programming. Right? One of the conventions is variable names always start with a lowercase letter, right? And classes and sometimes methods, which we'll get to later, always start with a first letter. And the reason for that is so if a programmer is looking at this and they see the word address with a capital A, they'll assume you're talking about some class or some method, right, called address, and not a variable, right? Again, that's not a rule. That's not a legal or illegal thing. It's just a convention in programming. Same thing with hometown. I made it all uppercase. All uppercase typically refers to something called a declared constant, which maybe we'll talk about later. Again, it's not a hard and fast rule. It's convention. But you probably ought to get in the habit of following that convention. So for straight variables, avoid uppercase first letter and avoid all uppercase, right? And we'll talk about when those are appropriate later. Okay, so what's an assignment going to do? Well, generally with an assignment, what you have is a variable on the left-hand side an equal sign, and then some value on the right-hand side. The simple version of how it works, whatever you have on the right-hand side is evaluated, and that's put into the variable over on the left-hand side. Right? Now, what you can have on the right-hand side is typically three things: a constant or a variable or an expression, and that's what I've got as these examples. X equals 42. 42 is a constant. A constant is simply something that does not change. In the case of a numeric constant, it is the symbols that look like the number you want to represent, which is an over definition of saying if you want to talk about 42, you type 42, right? So 42, that's a constant. Strings, if you want to create a string constant, at least for this class, you put it in double quotes, right? So, double quote James, double quote, that's a string constant. Okay, so the first one, x equals 42, means to evaluate the right-hand side, which is just evaluated to 42, and you put 42 into x, into the variable x. Okay? X equals y means you take whatever's currently stored in y and put that value in x. So y being another variable means go and get whatever's currently in y and now basically copy it into x as well. Okay? Let's see. Keep in mind that if you say something like x equals y and then on the next statement you change the value of y, that doesn't retroactively change what was in x. Okay. Occasionally people will come in and think kind of the way like Excel works. If you change what's in a cell, it kind of recalculates everything. Doesn't do that generally in programming. Programming things take place at a specific time. If at this moment you say x equals y, and y is currently 5, you put 5 into x. If on the next statement you change y to 12, that doesn't go back and recalculate what x should be, right? Okay. The last example there, you have x is equal to an expression, which is simply usually some kind of mathematical operation which results in a value. So once again, you got to find out what's in y, add 42 to it, and whatever that is, you put that in x. So if y was 5, right, 5 plus 42 is 47. 47 gets placed into x. X is now 47. Okay, so those are the three possibilities. There are some rules, right? Rules, the left-hand side must be a variable. This is going to come up in homework, right? What's illegal? Things like 42 equals z, or double quote James, double quote equals name, right? You cannot have a constant over on the left-hand side of an assignment. Again, the idea here is that what you have on the right-hand side is going to be placed, what's on the right-hand side is going to be placed into whatever's on the left-hand side. So that means these two statements don't have any meaning, right? You can't change the value of 42. You can't set it to something different. You can't change a constant James to something else. Okay, so it's got to be, left-hand side must be a variable. The other thing is the types of the left-hand and right-hand sides have to match. Okay, in other words, you're going to specify what these variables are, what type they are. And in this class, it's very simple. It's just numeric or strings, and that's all we're working with. In Alice, actually, we work with some other types as well. So in my examples, if z is a numeric and name is a string, the following are illegal. Setting z equal to double quote James double quote. Double quote James double quote is a string. So you're trying to put a string into a numeric. So that's illegal. Okay. Name, which is a string, if you set it to 42, you're trying to put the number 42 into a string, and generally that's illegal as well. Okay. On the homework, there's some questions about, is this legal or not? And watch out, the meaning. You may look at the statement and try to read more meaning into it than what's really there. Really, it just comes down to these rules. Okay, left-hand side has to be a variable. Both sides have to match. Anything else, even if it seems illegal in meaning, it's not really an illegal statement. There's my hint. All right. So finally, that's pretty much it for Chapter 2. Do be sure to read that chapter because there's a lot more information in there. than what I covered here, but this was essentially the basic information that you need to know. Your three basic structures, and of course we get started with sequences, and then this whole idea of assignments. Part of the reason for looking at the chapter too is there's a lot longer discussion of how to do expressions and dealing with variables and things like that. Okay, but that's basically summary of chapter 2. I'm going to